Here's another property of indefinite integrals. So we've seen all these in one of the earlier videos, and in the previous video we've seen this one here. Now we are going to look at this one here. So what this one is saying is that if f of x, so if you have a function f of x here, and then you have another function g of x, if f of x is always bigger than g of x on this interval here, on a and on this interval here, then the area of the purple, then the area underneath f of x, so that's this area here, then this area here, hang on, then this area here will always be bigger or equal to this area here. Okay, kind of obvious, but by using this here, this here is kind of obvious, but by using this, you can create something that is quite amazing and not so obvious. I will give you an example in the future, but this here is quite obvious, but you can use this obvious thing here to create and come up with something that's not so obvious. Okay, and so what this is saying, hang on, if f of x is always bigger than g of x on this interval, then the area underneath f of x will always be bigger or equal to the area of the g of x. Okay, so this here will always be true. So something similar to this would be this. Hang on. Something similar would be if f of x is always bigger or equal to 0 on this interval, then the area underneath that function must be bigger or equal to 0. Kind of obvious. If f of x is always bigger than 0, if f of x is always above the x-axis, then of course your area will always be bigger or equal to 0. Kind of obvious. Okay.